See, we got someone in here. Get started in a few minutes. I can see if you put something in the chat. There's also a link in the description that will allow you to vote on what topics we'll cover, which is hopefully working. Very strange doing this way. I can't hear anyone. I can't. I shouldn't get total real-time reactions. The chats come through pretty quick, but you're probably about 20 seconds delayed from me. Oh, cool. I see Sam and Dad are in. Thank you for coming. I'm gonna try something. Hopefully this doesn't break anything. There we go. Got that animated. Get some sound. Let me know if any of the levels on the sound is weird. I have very little streaming experience, so. Both the video and the audio you're hearing right now is 100% AI generated. I discovered the hard way that you actually have to verify yourself to get links on YouTube to work. You have to literally take a 6-second video of yourself proving you're a real person, or YouTube links just won't be clickable. Which is kind of weird. Yes, I'm brainwashing you with this music. The music's programming you to think this presentation's awesome. It has been stuck in my head because I had it playing quite a lot. Honestly, I was trying to emulate how the cool tech companies, they have the live streams, the pre-roll. It's not when they're waiting to start, like this. They have the cool visuals and stuff. So I'm trying to rip them off. Alright, we're up to 6 people. If you missed it earlier, there's links in the description below. That feels weird to say. I've never done it before. Links in the description below for, first one is for voting on what topics you want to cover. We'll come across that as we go. And the second link is for feedback. You can wait till later for that. It'd be nice if you do, but no pressure. And of course I can see chats. streaming's pretty new for me, so bear with me. Alright, I'm going to turn off. I have an earpiece in so I can hear the audio, but I'm going to turn that off because then I hear myself on a weird delay and mess with my brain. So, everyone keep me honest if the audio levels are weird at any point. There's only a couple. There's only like one or two things that actually have audio in them that will be going over. Mostly this first screen, I wanted to make sure it was reasonable. If you joined just a few minutes ago, both the visual and the audios, or the sound you're hearing right now is AI generated from two different sources. I told it kind of like I want something techy and cool and dramatic, and this is what it came up with, so I thought it was pretty good. I went through a couple iterations to find what I liked, but I mean, it was 10-20 minutes of work. Okay, I'm gonna give it one more minute, and then we'll go ahead and start. Because frankly, if someone misses the very beginning, that's fine. I don't really care. People can join and drop whenever they want. Yes, Hunter, you can chat now. Thanks for coming. Alright, well, I guess we'll go ahead and get started. Preface for all of this is this presentation is not completely finished. It's 90% of the way there. I appreciate you all coming to pressure me into getting it to 90% by now. Hopefully in the next 2 days, get the last 10%. You may not even notice, but some of these things, some of these slides will be a little rough around the edges. Feel free to put chat questions in there and ask follow-up stuff like that. I'm gonna try and be as interactive as I can, but yeah, streaming is a little weird. I'm already discovering, so this is a fun experiment for me. I don't know how useful it'll be for actually figuring out how to do this presentation, but it's fun anyways, and I want to share it with more people. So even if it's useless to me, this is fun. But I think this will be really valuable as well. So yeah, let's get started. All right. So who am I? I am Maxwell Mullin. I'm pretty sure everyone on this call, or on this this stream knows that already. I'm from Troy, Ohio, or I live in Troy, Ohio right now, but I'm originally from Yellow Springs. So eventually, my wife and I would like to end up in Yellow Springs, Ohio, but that may be a little while yet. I graduated from Ohio University with a bachelor's in computer science, and I currently work as a data engineer at 8451, which is really just a section of Kroger. I just want to clarify, this presentation reflects my personal opinions. It does not represent Kroger's or 8451's. I really want to respect that, that they are not part of this presentation. So, a little bit about me. I've always been into computers. There's me with Dad programming. He actually had a disconnected keyboard in front, so Max could type on the computer with him. In high school, I started a computer club, and and we worked on computers and talked about computers and learned about computers, and we even built a computer in Minecraft. It wasn't very advanced, but that was my senior project, is developing a computer as a collaborative effort with high school students. So computers have always been something that really interested me, but where artificial intelligence really became a fascination of mine was actually at the Little Art Theater. I remember long ago, my mother, Carolyn, said, we should really go see this movie. It's an old one, but you'll like it. And, oh, fine, go, teenager me. And it was this movie called War Games. War Games is a Matthew Broderick, is that how you pronounce it? Anyways, it's a movie about a teenager that hacks into the U.S. government's fancy computer called Whopper, which is learning how to best solve a nuclear war, and how to win. And it's a dramatic sequence of this computer learning and figuring things out. And, anyways, that really fascinated me when I was younger. That was kind of my first introduction to a computer that could learn, fictional as it was. I've for a long time been inspired by the idea of a computer that could do some of those things. So that's kind of how I ended up at 8451. 8451 is a marketing intelligence company, which means nothing to anyone. Basically, 8451 processes a lot of Kroger's data in order to figure out how to best optimize the shopping experience, whether it's digitally online, the paper coupons you get, how the store is laid out, things like that. It's all, we're baked in at every layer. So a great playground for someone who wants to make machines that learn. I actually don't end up doing a lot of machine learning in my job. As a data engineer, my job is more focused on moving data and preparing it and combining it and munging it is a term we like to use a lot, into the formats that we need for either the machine learning or the statistics that we end up doing on that data. So some of how I satisfy some of that itch at home is with my home server, and this is actually a recent picture of after we, my friend Brady and I upgraded the computer to have extra compute. This is a silly side project that's grown and been a real passion of mine. So you might say I'm into computers and AI. I think you should be too. So today I'm hoping to excite you about AI and then start you on the path to leverage it for yourselves. So this is a massive topic. This is like presenting on biology or something like that. There's like a ton of research in AI right now. So we're going to have to move at kind of a almost disrespectful pace. We're going to have to gloss over a lot of stuff. So this is really just intended to be a starting point where if you wanted to learn a little bit and maybe learn what there is to learn, that's what I'm hoping to do. So let's define a couple terms so we understand each other as best as possible. Let's talk about a program or algorithm. A program is just a rigid set of instructions that a computer follows to perform a task. So a program can be, I think we're all pretty familiar with a lot of programs, but generally speaking, you might have an email program like Outlook, and like when you use Outlook, it doesn't change every time you use it. It might have an update that changes its behavior, but it's following a rigid set of instructions. It's not adapting as it runs, unless some developer is going and like making a new program that does something different, but it's a separate program. I don't know if that makes a lot of sense, but so AI, distinctly from a program, it's really a special kind of program that learns from data how to perform a task. And what that means is there isn't an engineer saying if the ball is red, then put it in the blue chute. There's no logic like that, or there's at least some stage within that program where the AI is learning from the data of, when I put the red ball in the blue chute, I get rewarded, and that's information I've learned and a pattern I've recognized, and I can continue to execute against that. So the difference between a program and artificial intelligence, or machine learning, is that adaptability, that it's not bound by what the original programmer baked in to the logic. All right, then we have large language models. This is like ChatGPT, if you're familiar with that. This is kind of the new hotness in artificial intelligence. It's just a special kind of AI that's trained on like large, massive, really amounts of text data. So a large language model is very good at understanding natural language. I want to talk to you about why artificial intelligence matters. And this might be a little bit of a strange take, but I don't know if anyone remembers Palm Pilots. It's a personal sort of notepad. You could keep your to-do list and your calendar in it. They're very popular before phones were really a thing. So you might remember that they had a funny way of writing on them called graffiti. And this is because back in the day, handwriting recognition was a very complicated problem to solve. People had made different attempts to solve this problem of like, how do you turn, these arbitrary squiggles into letters correctly and reliably. From the 1960s until 1994, when graffiti was finally first released, people really worked very hard to make a solution. And graffiti is actually a compromise, right? It's a narrow way of writing your letters so that the computer can understand what you're writing. And that was cutting edge at the time, right? It was a big deal. There's lots of different variations of specialized handwriting that you could do to make a computer recognize it, but no one could do like generic handwriting. And now today, that's not like that crazy of a thing for a computer to be able to do. Like your iPhone can do that, no problem. And in fact, when I was in college in 2016, we trained a model to recognize digits, not handwriting, just written numbers. But we did that as an addendum in a class when we had extra time because the professor went through the material too fast. So artificial intelligence, and that was, we did that using some primitive artificial intelligence by today's standards. That was only possible because of artificial intelligence. We basically leapfrogged decades of research, and it was highly accessible to students that really didn't understand what they were doing. It's just a little extra in the class. So it really unlocked some ability that was not possible before. And I know that seems like really like, who cares about handwriting recognition? That's just like a simple example that's like very relatable, but you can imagine if you can apply that to much more complex problems, you can have much greater benefits. For example, suppose I am an AI researcher, right? And I am doing research on some specific part of artificial intelligence. There are anywhere from 50 to several hundred artificial intelligence papers published every day. That varies widely depending on when the last holiday was and other factors. But generally, there's a lot. There's more than any one person can really read and deeply understand while still having enough time to do AI research. So, if you have, for example, a large language model, you could ask that large language model to read through every paper that's been published in the last, say, week, and select the top 10 that are most relevant to your work, or summarize them into a more digestible format, not necessarily to replace your reading it, but make sure that you catch everything that comes through, and you can say, oh, this one's really interesting, I'm going to dive into that a little deeper, I'm going to read more about this, or this one, not for me, I don't really care about it, we don't have to read that one, great. So kind of sort of a search algorithm, but a little bit more intelligent than that. So in a sense, and my point I'm driving at is AI decouples our ability to think from our physical limitations. So I'm gonna drive why that point is important home in a second here. So I want you to think about that. AI decouples our ability to think from our physical limitations. There's a lot of examples in history that follow a similar sort of like decoupling of our physical limitations from what we can actually do. And you don't have to necessarily agree with me, but this is kind of the promise of AI, of decoupling that and making us able to do things we could not do before. Some of the examples of technologies like that we've had in the past, and this is why I say you can agree or disagree with me if these are on the same par, but I think they're close enough. So the internet and search engines decoupled information distribution from our own distribution, texts and phone calls and letters, telegrams, right? So, like, for context, XKCD estimates that in order for a library just to keep one paper copy of Wikipedia, right? If it's, say they wanted the Wikipedia book up to date at the library, you would need 6 printers printing continuously 24/7 at relatively high speed just to keep a paper copy around. Like, imagine the stacks of paper and the librarians like, oh, could you tell me about aardvarks? And like, these poor librarians would have to sort through stacks of paper to find the sheet, and it'd just be chaos. It'd be impossible. So with search engines and the internet, we've decoupled our ability to distribute information from our physical limitations. Computers have done the same thing on their own, or like separate from the internet. For example, your eyes respond to light hitting them. The signal of light hitting your eyes comes to your brain in about 250 milliseconds, which is pretty fast. A trading computer on the stock market can execute a trade in 1/300,000th of that time. It's about 800 nanoseconds, give or take, to the first byte of that trade being executed. It's just like unfathomably fast compared to what the human body can do. So we've decoupled our reaction time from our physical limitations, as well as obviously like doing large numerical calculations is also decoupled. Horsepower and steam engine. I think we can all agree that decouples our physical limitations from what we can do using machinery. The printing press, right? It decouples our copying of the written word, so you know, you can make copies faster than a human can push a pen, right? You're not limited by monks and chapels carefully writing out every word, and you get much more accurate copies as well. Reading and writing decoupled our record-keeping ability from our ability to tell stories and remember things. Yeah, fire and cooking. This one I think is maybe a stretch, but decoupled the amount of calories we could ingest from what our gut could process. You know, we could cook our meat and sort of make it more the nutrients more accessible to our gut. So that's kind of why I think AI is like a huge deal. It's like the ceiling for potential is, I think, clearly high, in my opinion. So let's define a couple terms of types of AI, or really levels of AI, and just to kind of level set, because I think, well, we'll get there. So first let's start with narrow AI, which is something I think we're probably most familiar with. Narrow AI is good at specific, well-defined tasks, and we're going off the benchmark of what they're better than a human at. So a narrow AI is better at chess, for example, than a human. And when that first really started to become available, it's kind of hard to nail down, but 1997 is the year where Deep Blue from IBM beat Kasparov in chess. It didn't beat him by much, but definitely they only beat him, I think it was like 2 of the games out of 3 that weren't draws. Deep Blue won. And that was really the moment when, like, it was like pretty clear that pretty much all computers could be better than all humans at chess. So that's narrow AI. If you give that chess computer the job of driving you around town, it's not going to go well, right? So it's narrow. Kind of just vanilla AI is generally good at broad or multiple tasks. So an example of that is like ChatGPT, if you're familiar with that, or autonomous cars. Those have started becoming available around 2022. Technically, autonomous cars were available first in 2017 or 16, can't remember. But like to varying degrees. So like just ballpark there. AGI is better than humans at all tasks, sort of. It's sounding like the definition for AGI is moving a little bit to all verifiable tasks, or some people have defined it as all economically valuable tasks. All of these definitions are my stab at it. There's not a good consensus on what exactly they are, so I'm mostly trying to establish a common definition for us to operate on. Whether or not it's exactly what everyone else thinks is not really important to this talk. So AGI doesn't exist yet. Depending on who you ask, they say, oh, it's next year. And some people say, not till 2050. Depends on your definition, really. I think we're a little ways out, but I think we're also closer than most people, like the average person understands. And finally, we have ASI, which is artificial superintelligence. And that's smarter than all humans combined. Now, we have no idea when that's coming. Some people think as soon as we have AGI, it's boom, it'll self-improve to be ASI. Some people think it's never going to happen. And frankly, we don't know. We really don't know. There's no way to know. Yeah. Oh, that's a great question. Sorry, I'm sort of reading the comments as we go. Let's see. The G in AGI is general, for general intelligence, meaning it can generalize to many tasks. It's not bound by some some smaller set. Admittedly, that makes my AI definition a little bit confusing because I also said multiple tasks here. AGI should be probably any task you can describe, it would be able to achieve, or maybe all economically viable tasks or valuable tasks would be a good definition there too. So, yeah, again, the definitions are kind of confusing right now because depending on who you're talking to, they will conflate these, which is fair. It's a scale. It's not there's not really clear edges to these definitions. Either conflate them or use the wrong one, or talk about one thing but they really mean the other. It gets confusing. So, anyways, so if you haven't already, go down in the description and there is a site where you can submit votes for what you would like to cover next. And I will try and do that. We'll kind of see where the votes land. I see my last update made that scroll, which is not great, but that's fine. So yeah, go ahead and submit your votes. And then if anyone has any questions, the way this talk is going to work is I'll go kind of down some... we're already half hour in, cool. We'll go down one of the topics and talk through that topic, and then we'll come back to this page. And whatever on this page, we'll do some Q&A. So if you have any questions, feel free to put them in the chat. For the actual talk, I will be answering them more immediately, but I'll try and catch up here. So, that's a really good question. So Mike is asking, what's the definition of think in the definition of AI? So that is a good, subtle question. I would define... thinking on it, I might avoid using the word think in that definition because, as we will likely cover, AI doesn't really think in the way we do. It's really easy to anthropomorphize what AI does as thinking, but it's really not. I think I would just avoid using that term. But we'll just say what we're really talking about in those definitions is whether or not it can successfully achieve those tasks at or above a human level, very generally. I think English struggles with a lot of computer science terms because, frankly, I think their computer science terms are just some of the newer terms out there, and I think AI researchers made a mistake in calling a lot of AI-related structures things related to brains, like neural networks is kind of a misnomer. It should be like linear algebra networks or something like that. But anyways, okay, so we got a bunch of votes in. I think, we have a three-way tie. Cool. So let's go into neural networks first, because I think that helps us establish more of a baseline for the rest of our discussion. So let's see if I can do this right. And then I think enter. No, not enter. Click. Okay. Okay, so let's talk about neural networks. Suppose you have some data. It doesn't really matter what the data is, but pretty clearly, let's see if I can do this right. There's some sort of pattern in this data, right? We have some x-axis. We don't really care what it is right now. And we have some y-axis. We don't really care what that is right now either. We just know there's some pattern. There's some relationship between x and y on this graph. Your first step to predict this data, which is our goal here, or you might say to model this data. Our first goal is, our first attempt might just be, well, let's just take the average right? Whatever the average value is, that's a decent predictor of this. So that would look like this. This is we have this horizontal line, and we're just saying this, the average value is this. So I put this formula in that way. And effectively that's like writing y equals 0x squared plus 0x plus 30. Okay. So I think pretty clearly we can all see an improvement on that would be to add some slope. Maybe, give it like a 3x, So that'll better follow the data. And in fact, I think we can all agree we can do better if we kind of tweak those numbers more, the coefficients on the different, on the x squared and x, we can do much better, right? We can add a little bit of curve to our plot line. Oh, I guess like a curve. Yeah, curve that way. The mirroring is getting to me. We get a little curve to our formula to predict the data. So what this effectively means is once I have this blue formula up here, how far can I go? Oh, I can go really far. Oh, okay. All right, so once you have this blue formula, if I give you an x value, you can somewhat reliably tell me what the y value should be for that data point, right? And I'm kind of purposely being really vague here because I want to make the point that this can work on any data that you can plot in this way, as long as you can you have a sufficient amount of data to make a plot, right? But to give it some context, let's imagine. Oh, sorry. You can write the same formula in this format with matrix multiplication. If you don't remember matrix multiplication, don't worry about it. Just know that we're writing the same formula in a different way. That's all you need to know. But anyways, let's say this is predicting the price of a house, right? So in that case, on our x-axis, maybe we have the size of the house, like the square feet or square meters or whatever. It doesn't really matter. The relative size of the house is on the x-axis. And on the y-axis is our price. And what that would mean is, with our new formula we've discovered, we can put in the size of any house and get an approximate price. I think you and I know that's going to be really terrible if it's only based on the size of the house, because there's a lot of other really important factors to the price of a house, like location or the quality of the house. So, case in point, we have, let's see, this dot here that's like an outlier in our data. Our prediction is really bad for this guy. And maybe that's because it's got a really crappy house that's not been taken care of as well as this nice, beautiful pink house at the top here. So while it's big, and our model predicts it should be relatively valuable, it doesn't live up to that. So we have a large error, or in some cases, well, not in some cases, in machine learning we tend to call it loss. Loss is how much error there is in your predictions. Okay, so remember that we've got this matrix multiplication for our formula. You don't need to understand how exactly it works, just that you know that you're giving it some variables. You have, in this case, we're taking x squared and x to the 0, which is really just 1, and multiplying it by some weights. So, oh, that's interesting. I don't know why that restarted the slide, but we'll power through, no problem. Cool. Again, we have a bug. How many times is it going to do it? All right, hold on. Technical difficulties. Can we... Oh, come on. Well, this is annoying. I have my presenter view and I can see what the next slide is supposed to be, and it's not showing up right. Come on. All right, well, we're going to just kind of go into this slide because it's close enough. It's similar. So one of the ways you can represent that formula, you're just going to have to imagine that I have a slide that makes it clear that that formula is the same as this structure up here. So we have up here this, can I reach all the way up there? How far can I go before it cuts me off? All right, so we have way up there, we have a neural network. And this is really just a representation of the same formula we just saw, right? So in our case, we have x to the 0, x to the 1, and x to the x squared being multiplied by some coefficient and then added together in order to give us an output, a prediction, right? So if you imagine, instead of doing x to the 0, x squared, and x to the 1, like, instead I put in different values. It doesn't have to all be on the x-axis. I could give it other data, like I could have size, location, and quality of the house. Some measure of quality, maybe a 0 out of 5 stars, or how many stars out of 5. I could take that data and do the same process, right? I could multiply those numbers times some coefficient and then add them together to get a value. That works pretty well, but if you think about it, that doesn't take into account any interdependency. So, for example, if I had my model predicting maybe it's just like 1 times each thing added together. So 1 times the size plus 1 times the location plus 1 times the quality equals my estimated price. That wouldn't work really well if, for example, I went out to a hardware store and bought 1,000 sheets of plywood and laid them out on the ground. Like, quality 0, but the size is just ginormous, right? And like, clearly the value of that house, if you would, a massive sheet of plywood, is very low, right? It's not going to match up with your model. So in order to take care of that, to take into account those sort of factors that affect each other, that are they'll affect each other anyways. In order to take it into account, that we add extra weights and layers, and that's what we're representing here. We're kind of jumping the gun to this slide because the other one's broken. So what we're seeing is on your left side, we have those 3 input nodes. That's where we put our values, right? So maybe 100,000 square feet, distance from New York City, and it's 3 out of 5 stars. Whatever your values are. Those are multiplied by weights, which is what those lines represent. The thickness of the lines indicates the strength of the weight, and then we add that together. There's some details here we're glossing over. Don't worry about it. And then we have another node, right? Just like another like our input from the previous one. And that would allow us to then repeat the process with other weights and make predictions based on more than one factor. I feel like I'm not doing a great job explaining that. But suffice to say, the larger you make this network of nodes, called a neural network, the more complicated patterns it can learn to recognize or predict. And the way we update those weights in order to efficiently recognize those patterns is a process called backpropagation, which I'm not brave enough to try and explain because it goes into like calculus, and let's just not go there. But imagine if you wanted to make a neural network that could predict anything that you can put into a neural network, you can imagine you put in your input data and you know what it should be when it outputs, and you compare those, and if the difference is large, then you change the weights a lot, and if the difference is really small, you change the weights just a little bit, and kind of over time you can make those weights operate in a way that'll recognize whatever pattern you want, and the more weights you have, the more patterns they can recognize, or the better they can recognize the patterns you want from other patterns. The example we have on the slide is actually getting into how large language models work, and we're like super glossing over a lot of stuff here, but imagine you wanted to predict the next word in a sentence, just like autocomplete does on your phone. You want to predict what the next word should be. You would need to put in the last 3 words that were written, and then it would predict the next. So here we have smile for the, and camera is the next word. So it's a very similar process. It's this very generalizable algorithm that we can apply to many tasks and predict a lot of different patterns. Yeah, we'll just go through large language model stuff here, even though that's not what we voted for. One thing you might have noticed is smile doesn't make sense to multiply by some weight, right? I can't multiply smile by 3 and get anything intelligible, right? Like, that doesn't make sense. So large language models actually do something called tokenization, which basically just means it breaks what was previously written, the sentence, up into small parts. A lot of times it's words, sometimes it's single letters. There's an algorithm for figuring out how to break them up most efficiently. But it converts each of those tokens, each of those little words, sort of, into a number, right? So smile might be 347, and 4 would be, maybe it's 4, maybe it's the number 4, and so on. And then you can convert everything into numbers, you run it through the neural network, and you convert it back into normal text. So yeah, let's just move on from that because we're taking a long time on that slide. So I would love to show you how that works. So this is Tick Tokenizer. You can find this online and use it for yourself. But effectively, you can type in things. So like, this is me typing. And you can see it's highlighted a couple tokens for us, so we can see how the model would break it up. And in fact, if you see, I can type totally random stuff, and you can see that up top it'll show what I can't even kind of reach up there. You can see the text highlighted, and you can see the numbers that it becomes for the model to operate on. Interesting side note with this. Let's see, can we, there we go. Oh, I'm clicking the wrong window. So let's see if I can do this right. So there's an interesting thing that's happened here. Normally, tokens are roughly equally likely strings of letters. They're grouped into equally likely strings of letters, sort of. And it's really unusual that this specific phrase, solid gold magic harp, has become one very large token. And this is actually a weird quirk of how large language models are trained. They're trained by literally downloading the internet, like every possible scrap of text that you can find. And some of it's junky, but whatever, right? So you train this model on all the data, and you decide how the tokens should be broken up based on that data. And this particular phrase was very common. And Funnily enough, that's because it's the username of a prolific poster on. I'm hitting the wrong buttons. It's from a prolific poster on the subreddit called R Counting. And I kid you not, there's people online that have been counting to, what are they up to? I got this recently. Yeah, 5.5 million. Is that million? Right. Yeah, I should know that. So Solid Gold Magikarp was a user. They've since deleted their account because they became famous for this. They were a user that participated in this counting online. Literally, people just posting the next number to each other, back and forth, back and forth. And the model picked up on that username and decided, oh, we'll make that a whole token because I see that so often that it'll be easier to just have that as its own separate thing. And a weird quirk is later, as data scientists were training their models, they caught this and they said, I don't think we should include this counting data in our models. It's not really useful to anyone. No one needs this. So they deleted it. And the upshot of that is, for a time, it's since been patched, for a time, if you talked to ChatGPT and said the token, Solid Gold Magikarp, it would absolutely lose its shit. It would get confused, it would sometimes curse at you, and that's because if you imagine these models, they're trained on these numbers that represent, words. But if a model was never trained on a specific number, it has no idea what it means. It's like showing a person a color they've never seen before. Or I've actually heard someone describe this as someone suddenly gaining an extra sense, like suddenly can sense magnetism or something like that. It's like very confusing to the model. So just a weird little quirk with that. I'm going to gloss over this a little bit. There's this really cool website where you can go in and see how these large language models work visually, and it even goes through and talks you through the different structures and animates them. Super cool. Highly recommend checking this out. I will have a page of links posted probably tomorrow. But I wanted to show this because I want to show that there's a lot of complexity here that we're not covering, specifically the transformer model, which is what this is covering. And it's just a special way of taking all these weights and these formulas and kind of weaving them into each other in a way that you get a lot more performance than the basic neural network we've been talking about. But in principle, the same ideas are the same. It's a good mental model. If you understand neural networks, you can kind of extrapolate reasonably accurately to what these other larger, more complicated setups can do. I also wanted to stress the scale of what we're talking about. This is Nano GPT, which is a toy example, and each of these, well, hold on, let me, this is hard to do on a trackpad. Each of these little dots here, I don't know if you can see that, each of these little dots is a weight, right? A weight in the model for how, like a connection in our neural network, right? So this is Nano GPT. It has 85,000 connections. Let me just zoom out and show you GPT-3. So I don't know if you can see it, but there's a little speck up here at the top left where my cursor is. Oh, maybe you can't see my cursor, I'm not sure. Anyways, at the very, very top of the screen, way up there, there's a little speck. And that spec is Nano GPT, what we were just looking at, which is quite complicated on its own. GPT-3, very, very big, and this is nowhere near how, they're so much larger than this now. We're probably, it's not for sure, probably into the trillions of weights for these really advanced models now. Okay, cool. That's a high-level overview of LLMs. You got 2 for free. Let's go below. Let's go back, please. All right, we're going back to the voting screen. Submit your questions now. All right. not sure. You know, I'm not aware of the recent mapping of the mouse brain. I do know there's been some really fascinating developments in just like brain simulation in general. There's a project that was done a while ago that actually simulated a bee brain, and they were able to get it to fly a drone. And they did it by basically mapping out the physical structure of a bee brain and letting the drone figure out things for itself, and apparently it worked. So I would not be surprised if AI was involved. I'm also noticing that we're already at like an hour. And that's about how long this talk's supposed to be, so that'll be interesting. I need to talk less. All right, so we've got some votes for... we already did that. We can do conversational models, image and video, super intelligence and misinformation. Let's go to let's do misinformation, and then we'll do image and video and probably call it a night. I'm gonna figure out how we cut out a ton of content. Okay. So, misinformation with AI, there's a lot of different versions of different ways that you get misinformation from AI. This is one that I have personally experienced to some extent. Unfortunately, interviewing is now about 50% interviewing the candidate, 50% deciding if they're using ChatGPT or similar to help them. This is a real product. I think, can I play this video or is it? No, it goes straight there. So this is a real product you can pay for that assists you during your programming interviews. I don't think it's illegal, but I think it's pretty nasty. So I have genuinely had some interviews where I suspected, I don't know for sure, but I suspect that artificial intelligence was being used to assist, and even some where a candidate was lip syncing with someone else who was using the assistant to help them. It is getting egregious. Is a real thing, kind of concerning. We also have fake products. So this is a dress. I don't know. These are some clothes you could purchase online, and you see on the left, these are very convincing images of someone wearing a very nicely knitted fabric, but on the right you can see what you actually get is a t-shirt with the printed pattern on it. I think pretty clearly it's misinformation. I have a link here to a YouTube video I really highly recommend you watch. It's by Corridor Crew. They're visual effects artists that go through misinformation from AI and help you understand how to like recognize those telltale signs, as well as just like describing how they work in general, and even showing how they can replicate some of the results and do it for themselves. So like there's another thing I would love to include here. It's just like it's kind of hard to fit into a presentation. They have a whole thing about an AI that's trying to sell people on a magic prayer that gives them money, and it's lots of celebrities that appear to be talking about this magic prayer, and it's all artificial intelligence manipulating the way their lips move and generating synthetic speech and stuff like that. It's nasty stuff. So be on the lookout for that when you're out there on the internet. It's dangerous out there. Let's talk about a more subtle one here. If you ask a chatbot what another word for hue is, they will almost always tell you color, C-O-L-O-R. That's like completely fine, but what if I'm British? Right? That's wrong. So here, case in point, if I even add a "Hey mate," trying to prompt it like, "Hey, I'm maybe I'm not from the States," it will still say color with the American spelling. Um, so this is like a toy example. Like, who cares? Like, I mean, maybe someone cares, but I don't. But this is a good example of like there's bias in AI, and we're gonna see a lot of smaller cultures that aren't as represented on the internet will likely have certain things that just aren't caught in large language models the same way as American English is. So there's likely going to be some weird biases and culture shifts around that. That's is it for better or for worse? I mean, it's kind of a forcing function towards everyone speaking a similar language, which I'm kind of for. That seems like a good first step to fixing a lot of the world's problems. But there's more nefarious things that more nefarious biases that can be built into these models. For example, oh, we have the weird looping slide again. Okay, well, I'll just talk over the next one, that's fine. So, for example, DeepSeek is a Chinese quantitative analysis firm that put out a really impressive large language model somewhat recently, I think, just under a month ago. And this model is massively more powerful than anything else that's been publicly released, so you can download it and run on your own machine. So I've actually done this. I've downloaded DeepSeek, the full model, and run it on my machine. And if you ask it what happened in 1989 in Tiananmen Square, it doesn't know. But if I ask OpenAI's models, they do know, and they describe the massacre. Now, that doesn't necessarily it's likely that that's something that DeepSeek has specifically made sure that the model responds in that way to that question. But it certainly could be that it was trained on the Chinese internet, and that's not on the Chinese internet. We don't know. And at the end of the day, it doesn't especially matter. It's just a good example of these models can be biased. Oh, and I should clarify, when I say I download the model, like, it's not connecting to any Chinese servers. It has no phone home or anything like that. It's just those weights is what I've downloaded, the math. So once that's on my machine, its only reason to tell the truth or to lie is just that's what it was programmed to do. That's what it was trained on. Okay, back to the menu here. Come on. Oh. All right. Let's see. No new questions, but feel free to submit some if you got any. You can always also unvote for things. I don't know if I mentioned that. You can just tap on it again to unvote for something. I'm going to quickly refresh this page and hopefully fix some oddities on my end. Okay, hopefully that will operate a little better. Okay, we've got some votes for conversational models. Oh. That's a good question. So AI will hallucinate things. That's something we should definitely talk about a little bit here. So if AI hasn't been trained on something, it's still trained to predict the next most likely word. That's how large language models work. So if I ask it to predict something it's never been trained on, it's gonna just make its best guess, right? And so it can hallucinate things. That's kind of what we call it. So it's a real problem that was especially bad maybe a year or two ago. It's gotten a lot better now with tool-assisted artificial intelligence. And what that means is there's things that the AI can use to fact-check itself. How far into this do I want to go? Basically, the AI is able to execute a web search. It can Google things and then read web pages to check what it does and doesn't know. If you can imagine, a neural network is trying to make the best model of the world to predict what the next token is, right? What the next word is. And in learning all those patterns, eventually it's going to learn, presumably, how confident it is in something. One of those little parameters or nodes is gonna predict how confident it is in something. So, like, you can imagine, it may have learned to kind of hedge its answers when it didn't know something, and it turns out with some reinforcement, you can train it to recognize when it's not confident, and you can train it either to not answer and say, I'm not sure. That's pretty uncommon from a large language model. Or you can train it to recognize that and say, oh, I need to go and check the web for this. So, yeah. Yeah, exactly. Solid gold Magikarp is like a good example of, like, if it has something crazy, it will do some weird stuff because it just doesn't understand. Yeah, so you can program it to say I don't know. That's pretty uncommon right now. It's just like a little bit challenging. You know, if you imagine these models are trained on all sorts of, like, basically everything from the internet that you could possibly cram into these models. And what you need to train it to say I don't know is you need a data set of things that it doesn't know. You need to know things it doesn't know, and program it to say it doesn't know those things. Well, most of these large companies training the models, when they find something the model doesn't know, they train it on that, and then it does know those things. So it's kind of tricky. There is a solution. It's not super well implemented yet, because we know a lot more of what we do know, and we don't know very much about what we don't know. So you kind of have a chicken egg problem almost. Yeah, that's never admit ignorance. Yeah, I mean, be confidently wrong is kind of, it's rewarded for that. So you need to. This is actually where the next frontier of AI really is reinforcement learning, which is basically just ask the model something, and if it gets it right, reward it, and if it gets it wrong, punish it. There's some subtle differences to how we program them, or how we train them right now. So you can only really do that with tasks that are verifiable, meaning I can prove that they're right or wrong, right? If I need a model to tell me what the right color for the room is, that is not something that you can say definitively, this is right and this is wrong. Like, what color the room should be is subjective, right? Whereas if I ask it a mathematics problem, like, I can know what the solution is or what the formula should be or whatever, and I can validate that, like, okay, this is right or this is wrong. So AI is getting incredibly good at verifiable tasks right now. Literally last night, a new model came out from XAI that just trounces what we've had before, because it's able to reason better than other models. At least it seems that way. The public access is not great right now, is my understanding. I don't have access to it. But, like, they have the largest supercomputer in the world. They probably have the best model because of it. Time will tell for sure. Okay. Technically, we're probably well past time. Yeah, we're further than this should go. Let's see. I'm just checking because I can't see on my view how many people are actually watching. And if there's interest, we can keep going, but we can also end this. So why can't I open the stream? Can someone just comment how many people are currently watching? That might be the easiest. And or if you want to hear more, just comment something. Oh, thank you, Michael. If we want to keep going, we can. I'm just gonna assume we're gonna keep going, and y'all can leave whenever you want. It's good practice for me, anyways. Okay, let's look at. We could do image and video. Oh no, let's do conversational models. There's some cool stuff with that, and then we'll do image and video. We can just go from one to the other. There we go. Click. All right, so quickly, we're going to discuss what the Turing test is. This is Alan Turing. You may know him as Benedict Cumberbatch from The Imitation Game. There's actually a funny thing. The movie The Imitation Game has nothing to do with The Imitation Game. The Imitation Game refers to a Turing test, which is inspired by a party game that was played between people where a man and a woman would hide in two different rooms, and you would slide notes under the door to try and they'd slide notes under the door back and forth, and the players would try and guess which door the man was behind and which door the woman was behind, and they would try and fool you and all that. So, inspired by that, he said, well, what if instead of a man or woman you had a human and a computer? And if the computer can fool the player into thinking it's human, that's like a really good benchmark for how intelligent this computer is. And these advanced forms of AI we have now are passing that in certain circumstances. Some people say they've like blown past it, and some people are like, well, you have to get it in all circumstances. And so we're right around that point with AI right now. So a good example of that is this human does not exist, or this person does not exist. It's a website you go to, and it shows you a random image that is artificially generated. And I have this slide through. So these people are not real. They look very convincing. If you look closely, you can find some things that are like not quite right and determine their AI, but it's very hard to tell that this is artificial intelligence. So we're well past, in some narrow scopes, we're well past what humans can identify as real or not. And to that end, there's a wonderful game you can play, Human or Not, which is at app.humanornot.ai. I would encourage you to try this out. We'll skip over it for time, but you simply open the app and it will match you with either a bot or a human without telling you. And you have about, I think it's like 2 minutes to have a conversation with that entity. And at the end, you're supposed to decide whether or not that the person you just talked to is a human or not. I have found it actually to be relatively easy after a little bit of thinking, but I'm very curious to hear what everyone else has their experience with that. Let's see. Turing. Yeah, AI scams. I'm a little worried about that. They're getting more complicated. Okay, so go try that out. ChatGPT is the other most accessible thing in that realm. So I have ChatGPT pulled up. Gotta log in. Okay, so this is kind of the power of AI. I think you can use 4.0 for free. So this is where you can select what model you're going to use, but generally 4.0 is going to be what you want for most people's cases. And you can ask it anything. Anything you can come up with, anything you type out, you can ask it. So a question I've been liking to ask recently is, why are there 2 peak tides rather than 1, since we only have 1 moon. Right. This is I think, interesting physics problems, like why are there 2 peak tides every day instead of 1? It seems like it should be only 1 if you think like very intuitively. And we can ask it this, and it will list out a long reason. We won't read through all of it. Turns out it's because basically the Earth moves underneath the water in a sense, or yeah, because the Earth doesn't rotate around its own center of mass is the answer. But it's a really interesting question. You can get different responses. There are more advanced models. So like if I go to O1, let me copy that and let's start a new chat with O1. And O1 is a more advanced model. Cool, I didn't copy that right. O1 is a more advanced model. It's called a reasoning model. A reasoning model basically is much smarter because it kind of thinks to itself. It will, like you and I might, it will say, well, I'm going to break down the problem and think about, okay, so the Earth is here, the Moon is there, and like it's going to think about all this, and then it's going to give you an answer. So here is, well, that's a uninteresting. Usually it gives you a lot of texture. You can see like all the different things it's done. In this case, it has not thought very much, but it'll reason about the problem for a little bit, and then it'll output, an explanation about why there are 2 tides instead of 1. So I highly recommend you use this anytime you might Google something. ChatGPT is a great replacement for. Sorry, the cat feeder just went off. The cat's unplugged my computer. 1 second. Yeah, ChatGPT is a great replacement basically for Google. There are some things you need to be wary of when asking ChatGPT questions. Like, it doesn't always, it'll hallucinate things. So if it doesn't know about something, which is generally speaking, if you're asking about something that's not on the internet, then it might give you kind of garbage answers. So like a good example of something like that would be asking it about a very recent event can sometimes be an issue. Less so if you have, let me switch back to the other O4 model. If you have this button checked, the search model, it's not as much of an issue because it can go and Google whatever has happened. But that's because when it was trained, that whatever event hadn't happened yet, so it doesn't know about it. There's also other things you need to be wary about, like if you ask it a complicated question, or really any question, sometimes it just says wrong stuff. And some of that's because there's a lot of wrong stuff on the internet, You can Google things and find wrong things just the same way. So something to watch out for. You gotta think critically about the answers you get, but it's incredibly useful, much faster than Googling, really. Now I need to go back to here because that link was sort of broken. All right, that's conversational models. Go try them out. A lot of them are free. A lot of them are free, but you can pay for the better ones, kind of thing. Highly recommend familiarizing yourself with those models. Okay, we've done. Oh yeah, let's do image and video. I was gonna jump to that. So, we've been mostly focusing on large language models. I would like to show you some of what there are other kinds of models that can do video. Now, this is Sora from OpenAI. So this is I forget the prompt down here. You can see it. You can't see it here, but oh yeah, Burdens of Society is what this one's titled, which I think is pretty good. So video from AI can be pretty convincing. It's not perfect yet. Really, the scams you tend to see are actually real video with a little bit of AI overlaid, like especially for the mouth, for like changing the speech. But but clearly we can do full video as well. Like this is 100% AI generated. You get some absurd things that you definitely have never seen on the internet. Like I've never seen two monkeys driving a car like this. You do get some weird stuff. Like the physics is not quite right. Like I don't know if you noticed, but that martini glass seems to be just kind of floating. So there are some things that it doesn't do quite right yet. It's improving, but it's there's some weird stuff still. Or here's a box of chocolates with terrified faces. This is much more simple, so I think the AI does much better showing it, making it look realistic. And it can also do totally abstract things that aren't CGI looking stuff. So here you have like a little furry creature in a forest and all that. And these are all done by just writing in a prompt, some text. So let's go to Sora.com. Hopefully I can log in. This website's a little weird. Well, here, you can see like lots of different stuff that people have generated. If I log in, well, that's okay. I don't actually want to run one because I only have one more for the month. So we're not going to generate one for the rehearsal. But you can generate these relatively quickly and easily, and they are relatively inexpensive, especially compared to like real artists. It's just a whole other thing. Yeah, that's a good question. What's the most significant advantage to AI with AI for like a casual user? I think thinking critically about things. Search is really the big thing, right? So like right now, you can already Google something and get a lot of value out of that. I think everyone can agree Googling things is valuable. Imagine if you Google something and for example, vaccines cause issues, right? Whatever you want to say, autism or whatever. Like that is something you can Google and not get a somewhat unbiased opinion about, because if you Google it the wrong way, you're going to get those biased opinions back. By asking a large language model, you're more likely to get a more nuanced opinion, or at least one that's not being paid to tell you something, or making money off of telling you something. So I think that's probably the biggest advantage, is like I also call it like a critical search. And then there's other minor things like proofreading is probably really useful to most people. Certainly the largest advantage to large language models right now is programming. I think that's for sure. You'll also see large language models built into more and more products that you use. Like as a consumer, there's not a lot of use cases. Like the number of times I Google things on a daily basis for like regular everyday life things is pretty low. Like maybe 10 times a day at most. So there's not a lot of value in search. I think we're going to see it built into apps a lot more. For example, it used to be you could ask Amazon a question about a product, and it would send out emails to everyone that had already bought the product, or a lot of people that already bought the product, and ask them that question, and they would answer it, and that answer would get back to you over time. Well, Amazon figured out they could use a large language model to do the same thing instantly. So now you can ask their model, Rufus, I think, about pretty much any product, and it'll give you some information about it. Not always 100% accurate, but it's it'll summarize the comments that have been made, or the reviews really on that product, and any information on the product page itself, stuff like that. So I think we'll see it built into a lot of things. So it'll be useful for narrow tasks first, and I think in the next year or so we'll start to see like people who don't know how to program being able to write programs very easily. What was demonstrated last night from XAI made a game of Bejeweled and Tetris mixed together, and they were able to do that in a single shot, a game that worked. And you could imagine, you have a game that's like close, and you could say, hey, could you tweak it, like change the colors, make the blocks fall faster? You can ask it to adjust things. It could certainly do that. So I think we're going to see a lot more of the people who have an app idea get their app idea actually implemented, because it doesn't. The skill floor is dropping. Okay. Let's go back to the voting page. Also, if anyone has any thoughts on how far to streamline this talk, because we're definitely over time. Thoughts on I definitely like the scamming and the how to use it. I think are critical to cover. There's just so much to talk about in AI. We can't possibly cover it all. So, and I'll probably cut down some of my intro stuff too, because that's really not important to the talk. Okay, I guess we can do superintelligence. The purple monkey video off? Does it have sound? It shouldn't. Okay, well, I've moved away from it now, so I think probably with latency it's probably, yeah. Okay, cool. Yeah, as with latency, I was going to say, like, oh god. I did not realize there was sound. I assume you're complaining that there's sound, so I turned that off. Or I should mute that. I will in the future. Okay, so we'll go to superintelligence. Definitely not because I didn't write up reasoning models yet. Let's see. Let's see. There's superintelligence. It's kind of hard to see on this. It's okay, Dad. I can send you the file of the purple monkey. Okay. This topic's kind of heavy. We're going to start with the worst case scenario and then go to the best case. And so what we're talking about, I should preface this, we're talking about artificial superintelligence. And there's a lot of thought experiments that have made people worried about safety with that, and we'll kind of get into why that is. But I just want to stress that we really don't know, so all we can do is set an upper and a lower bound at the moment on like what things look like in the future. So anyways, I just want to preface that with this. I'm going to start with the worst case, then we'll go to the best case. So we'll start with the scary and then go to better. So let's do a thought experiment. This is a classic one. So the thought experiment, we're going to try and demonstrate that any sufficiently superior intelligence can't be controlled. All right. So imagine I am, I forget what the name for stamp collectors are, like a philanderer? Imagine I'm a stamp collector, and I happen to have access to a artificial superintelligence. And I ask that artificial superintelligence to add as many stamps as you can to my collection, right? What could go wrong with that? He said, foreshadowingly. So this ASI makes a plan, right? You would think, like, okay, he starts with purchase stamps online. Seems like a great move. Oops, it doesn't have any money, right? You just asked it to get stamps, so it needs to get some money. How's it going to do that? How about it sets up a GoFundMe fundraiser? Right, so it could be a GoFundMe for stamps, but it's probably going to get more money if it looks like it's a cancer survivor who's trying to pay their medical bills. right? Like, it has no incentive. You haven't told it not to lie, right? You've told it to get more stamps, and it's going to get more money and therefore more stamps by lying. So it's going to. Maybe it starts sending scam emails, oh, I'm a Nigerian prince and I just need a little bit of money to help me, like, it could start scamming people for money. Maybe it starts trading stocks, not, depending on your opinion, not inherently evil, but, it's going to start trying to gather resources, financial mostly. Or, shortcut, how about it just hacks the payment system for the stamp, some sort of online stamp store, or eBay, whatever. So now we'll say it's got as much money as it needs, right? And it could purchase every available stamp on eBay. Now, this might feel like a jump, but you have to remember, artificial superintelligence, we're talking about something that's smarter than all humans combined, right? It's going to easily be able to defeat basically any security system. It's going to be able to manipulate people in ways that are, undetectable. It's massively more intelligent than anything that we're used to dealing with. So you kind of have to suspend your disbelief on that. So maybe it runs out of stamps, so it campaigns to become postmaster and start producing more stamps. That's more stamps in the collection, so it's going to do it, right? Now it needs to increase stamp production, and maybe it runs out of the materials to make stamps. We don't have any more paper, so now it starts cutting down trees to make more paper for the stamps. I think you can follow the line of thinking that this is something that's spiraling out of control. And probably, well, I think I have this on the next slide. You're probably thinking, like, couldn't the creator just, like, turn it off as soon as he gets, like, enough stamps? Well, remember, the collector, asked the superintelligence to get as many stamps as possible, right? Give me more stamps. And you can imagine, if I'm the superintelligence and I do something that's going to make my programmer, collector, whatever, upset with me to the point that he wants to turn off me, the superintelligence, I'm not going to do that because I'm going to get less stamps if I get turned off. Right? So I'm incentivized to try and walk that line. Or, more frighteningly, I might be able to get more stamps if instead I do something to the collector that makes him unable to turn me off, right? I mean, the obvious one is, like, I kill him somehow, or perhaps I make a virus that only targets him and makes him dumb so he doesn't notice, or maybe I make a new super material and build a fortress around myself, right? Like, there's all kinds of different ways that I could do this to make sure that I get as many stamps as possible. Okay, so what about just reprogramming it? Say, like, well, okay, I said more stamps, but not that many, right? Like, maybe that. The thing is, the same problem applies. As a superintelligence, I'm incentivized to make sure I get as many stamps as possible. If I allow you to change my programming, and I do say allow because it's more intelligent than the programmer in that case, if I allow that to happen, then I will get less stamps. So I don't want to do that. So I'm going to do what I can to avoid that, and what I can do is quite a lot. So maybe you think, like, okay, it's really smart, right? Wouldn't it know that's not what we meant? Like, something sufficiently intelligent should have a system of morals or a conscience, right? I think there's two problems with that. One is that's anthropomorphizing this intelligence. We don't really know. Like, maybe, but we don't know. And the other problem is we also behave in ways that don't align with what was meant by our programming, right? Even though we know what the intention is, we do something other than that. So we call this an unaligned goal, or alignment more generally. If you are aligned with an AI, it's behaving in the way you want, right? So let's talk about how humans actually disobey their genetic programming. Um, some of our programming includes eating, reproducing, and protecting ourselves. Um, some people follow a diet. That is good for us overall. I think it's clearly good for us, but we are genetically programmed to eat more food if we feel hungry, right? And we've broken away from that by following a diet. We use birth control, right? We have a reward circuit for reproducing, which we have managed to hijack and take advantage of, despite knowing why that circuitry in our bodies exists. This is a really interesting one. I actually wrote suicide here, but then I had an AI reformat my presentation, and it rewrote this to engage in risky behaviors, which is an interesting change. Just thought I'd bring that up. But like clearly, we have goals that are programmed into us that we do not follow. And there's no reason to say that's different from an artificial superintelligence having a goal programmed into it and saying like, well, I know what I was supposed to do, but this is a better way to do it, or to override some of those limits, you know. There's a quote from Stephen Hawking that I'll read here. A real risk with AI isn't malice, but competence. You're probably not an evil ant hater, but if you're in charge of a hydroelectric green energy project and there's an anthill in the region to be flooded, too bad for the ants. I think that's the point, is like, it's hard to imagine an intelligence so much greater than our own, but that's kind of what we're talking about. It's not even for sure that this is possible. Like right now, we are definitely constrained by the number of electrons we can push into a computer. That constraint is limiting how smart these machines are, and how much time they have to train. So like, I don't think we're particularly close to this, but this is what people are thinking about, like, how do we handle artificial superintelligence if and when it does arrive? Because it is a very challenging problem. If you're interested in sort of this line of thinking, there's a wonderful short film, award-winning short film, called Writing Doom, which I recommend you look up on YouTube. I think it's a half-hour long, and it goes through a lot of these discussions, some of the literal talking points that I've brought up here. It's just a really accessible way to talk about artificial superintelligence and why it's just it's a really hard problem to wrap your head around. So I kind of already talked over some of this, but some reassurances. We don't even know if it's possible to make artificial superintelligence. Today we certainly don't have ASI, and we might not have AGI. It kind of depends on your definition. We're getting close on AGI. And AI safety is like actively being researched all the time. All right, so let's talk about the best case. Let's lighten the mood a little bit. I don't know if this is going to work. We're going to try. This is a recording of Steve Jobs.
I remember reading an article when I was about 12 years old, I think it might have been Scientific American, where they measured the efficiency of locomotion for all these species on planet Earth. How many kilocalories did they expend to get from point A to point B? And the condor one came in at the top of the list, surpassed everything else. And humans came in about a third of the way down the list, which was not such a great showing for Crown of Creation. But somebody there had the imagination to test the efficiency of a human riding a bicycle. Human riding a bicycle blew away the condor, all the way off the top of the list. And it made a really big impression on me that we humans are tool builders, and that we can fashion tools that amplify
I can
these
turn it up a little bit,
inherent
sorry.
abilities that we have to spectacular magnitudes. And so for me, a computer has always been a bicycle of the mind, something that takes us far beyond our inherent abilities. And I think we're just at the early stages of this tool, very early stages. And we've come only a very short distance. And it's still in its formation, but already we've seen enormous changes. I think that's nothing compared to what's coming in the next 100 years.
Okay, so I couldn't hear that, which is fine, but it's a little confusing for me. So, I think there's a case to be made that AI is a bicycle for the mind. If you think about it, we have many different layers in our brain. We have the brainstem, the basal ganglia, limbic system, neocortex, prefrontal cortex. And you could argue that there's a world where ASI becomes an exocortex, a brain outside of ourselves. And maybe that gives us some abilities that we didn't already have. A lot of these other layers gave us similar, or gave us abilities we didn't have before. For example, the limbic system giving us emotions and memory, neocortex giving us better sensory perception and cognition. Prefrontal cortex has been massively helpful for everything in the modern day life. And I want to make the case that that having an exocortex is a good thing, if that is the future we're headed for. The brainstem, similar to our current situation, the brainstem has been taken over by what is effectively an artificial superintelligence, right? It's an intelligence far beyond its own. Like the limbic system. And the limbic system has been taken over by the neocortex, and the neocortex is taken over by the prefrontal lobe. Sort of, I would say maybe taking over is extreme, but I think it's fair to say that's been very beneficial to each of these layers. Birth control is a great example of it's been really great for the limbic system. That's worked out great for the limbic system, and that is very much a product of the prefrontal cortex. So I think there's some argument to be made that exocortex, if that is the future we're headed for, could be really good. We could have sort of better solutions for ethics or strong empathy or morals, things that currently today do not are not well understood and solved, and we don't have a good it's not something we operate well on right now that maybe we could with exocortex, and probably some things we never thought of. I'm sure the brainstem never thought about having emotions, so we don't know. There could be wonderful new things we're gonna learn. As a bit of a fun exercise, I actually plotted out the emergence of each of these, and if you fit a line to the emergence of each of these, it actually looks like the exocortex should have emerged either 300 to between 300 and 600,000 years ago. So we're actually overdue for another layer in our brain, you could argue. Yeah, I don't know. So I think there's a world for there's the ceiling for where artificial super intelligence can go is very high. The floor is also very low. It's just a very big unknown at the moment. All right, I think that's the end of that. Okay, up and over. I suspect, yeah, we're at 8:13. So I'll hang out on this slide for a moment to answer questions, and then I think we'll call it for tonight because it is way past where the talk's supposed to go. If you haven't already, I'd love it if you could give some feedback in the forum below. If you have issues with it, just send me a text or whatever. The talk is in 2 days, so I'm gonna have some work to do to pare this down. Probably should have done some more run-throughs earlier, but that's lessons learned. Yeah, so post anything in the chat if you have any questions, but no problem. Philatelists. That's what they're called. Thank you. I didn't see that earlier. Okay, I think that's about the latency, so I think I'll call it here. Oh. Oh, you're very right. Yes, philanderer is not the same thing. Thank you. Yeah, we'll have to be careful about that one later. Okay, cool. Well, I really appreciate everyone providing feedback and whatnot. This has been a lot of work to put in, and I do plan to. I'll publish all the links to the various resources here in the near future. If I'll link it on this recording, it'll be on my YouTube channel. But if you just want like a straight link to it, just let me know and I'll text it to you. It's no problem. I'm planning to make each of these segments into like blog posts on my blog. So if you want to learn more about this stuff and dive into the topics we didn't today, you can do that. It's going to take me a little while to get them all out into that format, but that's just something I want to do over time. Because I think it's important for people to understand how AI works and how it's affecting everyday life, because the rate of improvement is flabbergasting. It's ridiculous. It's absolutely ridiculous. Yeah. Cool. All right. Thank you very much. Everyone have a nice night.